Are you looking for a smooth, powerful, and very torque-dense motor for your RC rock crawler? Well, you are in luck, because today we are talking about the V2 of the Puller Pro. I'm John Holmes, and I appreciate you tuning in today. I'm very excited for this video because we're going to go over the version 2 of our Puller Pro rock crawler motor. So I'll start with why you would want to choose a Puller Pro in your rig. It is one of the industry-leading smooth startup motors. At the same time, I have packed as much power into the can as possible. So not only do you get a lot of torque density, you get a lot of power density. Power density that has been proven for many years in the U4 rock racing scene and pretty much rock crawlers around the world. It is a 4-pole motor. We have had this in our catalog for many years at this point, and I figured it was about time to do a little bit of updates on them. So first, we'll start off with why you would want to choose a Puller Pro. Well, it does have the industry-leading smooth startup for an end runner. And that, for most rock crawlers, is priority number one, including myself. We spent a lot of time getting the stator and the rotor shaped just right so that we had just as smooth of a startup as we could, very usable, yet you can still have a whole lot of flexibility on your wheel speed. So not only does it have industry-leading startup, it has really good power and torque density. And we can show that by showing you what a 2-pole motor, a standard 540, looks like next to our stubby. Now the stubby produces more torque and power as compared to this 2-pole, or we can compare it to our standard size, which is a standard size 540 can, but it packs a wallop. It is about 60% more motor than the stubby size, yet just crammed into a standard 540. So if you're wanting something that's extremely flexible, something very power dense, very torque dense, the Puller Pro, especially the standard version, is extremely flexible in that manner. Or you can get the stubby version and you can have all the power and torque that you really need for most vehicles, but it is in a smaller, lighter can, which is really useful when you have a tight interior, if you're doing competitions and you want to shave a little bit of weight, or if you just really don't need parts breaking power. Although it still has parts breaking power, it's not nearly as much as the standard 540 size. In a lot of my builds, I do kind of lean towards the stubby because it starts up a little bit smoother and it's a little bit more controllable under most situations. But for parts breaking power, for big rigs, 2.2s, heavy rigs, something where maybe you don't have enough gear down, the standard is really one that shines in those sort of situations, which we're going to check out in the Capra a little bit later. So what did we do to the version 2 of the Puller Pro to make it a little bit better than version 1? One of the things that we did is we added adjustable timing on there. And although it's not needed in all installations, when you have a reverse rotation installation, it becomes very handy when you need to tune it just a little bit. We also changed our sensor port to come out at a 90-degree angle, and this helps clean up your wiring a little bit, and it also makes it easier to waterproof the motor. Another thing that we did is we changed the rotor just a little bit, tweaked the dimensions on the rotor as well as the shape of the magnets, which gives it better drag brake, more torque, yet it doesn't really sacrifice your startup. It still is an extremely smooth and tractable startup, which I really love. So along with the adjustable sensors, we also made the sensors more accurate at the same time. And this really helps when you're trying to put a lot of power down, when you are trying to use this in, say, a racing situation, U4 racing, or anywhere where you need the most effective sensors on the startup for commutation, and you don't want to sacrifice any of your efficiency. So we went ahead and upgraded that at the same time. Along with the sensors, we upgraded our solder posts, and we can just look compared to this guy, much thicker solder post, much more copper on there. The downside of that, it is extremely difficult to solder with most at-home soldering stations. So if you need to shorten your wires, what I would recommend is you actually take your bullet plugs off and move them down the wires. You'll have a lot easier time doing that than trying to desolder right here. If you do want to desolder right here, I would suggest that you put this in an oven at 140 to 150 degrees Celsius to bring the motor up to temp so that it's not wicking away all of your heat. We also kept the very large face bearing on this. You can't see it because it's hidden inside the can, but it is an extremely large bearing, has really high radial forces to it, and we have shown on the version 1 that it is much more reliable than the much smaller bearings that are typically included on these sizes of motors. If you do have any more questions about what we changed on this, some specifics on there, be sure to ask down below and I will get to them for you. So what we're going to do now is compare the rotor of the stubby to a normal 540 size motor. And this rotor actually comes out of the Castle Slate motor. And they're great motors in their own rights, for sure. They're high efficiency. They did a really good job on their engineering. However, I don't adhere to racing rules, so I typically will make mine shorter. So this would be our 540. This would be our stubby. This is what comes in pretty much all 540 motors from other manufacturers. Again, nothing wrong with it, but I like to do my part to really tune motors to be the best. And what we're really going to be looking at here is the active length, and see if I can get these as close as I can to each other. So the active length of a rotor or a motor is going to be the stator length or the magnet length. And as you can see, it's pretty much within a millimeter. I believe the Castle one is 16 millimeters long and ours is 15. Let me just double check. Yep. So as you can see on the active length, it is extremely close to a normal 540. Due to our larger rotor size, really can't tell a difference as far as the torque and the power output. So that's pretty much what I did. I crammed as much motor as possible into a nice and short motor. Woo! And the magnets are nice and strong. There we go. At this point, I would like to go over the waterproofing that you should do if you're going to get your motor into water or mud. While these do have a relatively sealed case, there are a few points where water can ingress into it. And it's pretty easy, honestly. I would suggest this for people that are getting into mud, for sure. So down at your local auto parts store, this CRC dielectric grease is relatively inexpensive. It's got a big package, it goes really far on motors. This is what we use in the shop in most cases, is this particular dielectric grease. You can get it anywhere. So what you will do is apply dielectric grease to right here around the bearing. And as you can see, I actually choked it down as compared to our previous version. Here's our previous version, version 1. You can see a lot of that bearing there. I choked this down so that you can just put a little bit of grease in there, and that will keep water from coming through your bearing. We could have used rubber shielded bearings, but due to the high RPMs of these motors, they wear out the rubber shielded bearings fairly quickly, and instead of having to replace those every 50 to 100 hours of run time, you can just put a little bit more grease on there. The next place that you should add a little bit of dielectric grease is to your unused motor holes. Most people have a little bit of problem when they get into mud with debris getting into the motor through those unused motor holes. So just fill them up. Honestly, you can't really use too much, but I wouldn't suggest throwing many cc's into each of these holes. But just basically put some on your finger, wipe them over those holes. Alternatively, you could use a piece of tape across the face and then just poke open which holes you're going to use to mount it. Along with the front side of the motor, on the back side of the motor, if you would like to increase your waterproofness, we have conformally coated the sensor board, so you're okay there on the insides. But what I would suggest is adding a dab of dielectric grease around the edge of the sensor board or the sensor plug right here. Fill up the actual sensor port itself with grease. That is always a good idea. It doesn't even matter if you're getting into water. I would highly recommend that. And then add a little skosh of dielectric grease around right there where the wires go in. And there's actually not going to really be much egress of water into the motor from that, but it's always a good idea to just kind of cover your bases and make sure that you are very waterproofed. Now, if you don't feel that you did a good job on waterproofing, or if you feel that you're just kind of nervous and you don't trust it, then what I would suggest is that you tear down your motor whenever you get it dunked underwater. Even the most waterproof and sealed motor will end up soaking water into it over time, because it will either have a heat cycle where it heats up and then it cools down, and any water that's sitting around the motor will get sucked in. It really does, even if it has rubber shielded bearings on there, even if it has rubber on these areas where it bolts together, it will end up soaking water in over time, or at the very least you will have humidity condensating on the inside of your motor. So if you run on a high humidity day, then you let your motor cool down, it will have condensation on the inside. And that is one thing that over time will end up destroying a motor, and we do see rust on motors coming in where the person has never even gotten it into water. So especially if you live on the coast or in areas where you have days that have very high humidity, just be sure that you crack open your motor every now and then, make sure you dry it out, inspect it, and you can catch any rusted bearings before it causes a problem, before they destroy it and end up causing more damage to, say, the rotor or the stator. So just my recommendations on there. Many people really don't have problems with them. You can get these into water without a problem, but I'd rather be on the safe side, because let's face it, these are not inexpensive motors, and I don't want to see a customer end up getting them wet, having them rust, and then not knowing why. So just a word of caution. Please add a little bit of dielectric grease if you are going to get them wet, and it's a good idea to tear them down every now and then. If you don't feel comfortable with them, of course, you can send them in to us. So now I think I've talked about all the features that I possibly can on these motors. Again, post them down below if you got more questions, but I think it's time to go check them out. So what I have is a Puller Pro Standard shoved into the Capra, and the Capra doesn't really fit 540 motors that have square cans very easily, but this little chamfer that we added to the back of the can ends up making it bolt right in without any modifications. You don't have to cut that 4-link mount on the rear or anything. I would really recommend using that standard in the Capra if you possibly can, because it is a beast of a motor and will have much higher torque and drag brake, which I think translates into a much more consistent drive on the rocks. So speaking of driving on the rocks, we are going to go out there and test her out. We are outside with the standard size Puller Pro V2 in 2200 kV installed into the Capra. And we'll just display a little bit of low speed control here. Now it's a pretty tractable motor, but it still has a lot of wheel speed, especially considering the Capra's gearing, which is why I chose the 2200 with an 11 tooth pinion currently. So now we're going to do a little bit of a speed run here. And again, that is the 2200 kV with an 11 tooth pinion running on 3S LiPo. Now, one thing that I would like to mention about the Capra is that right now I believe I do need to shim my pinions a little bit in like the ring and gear, you know, in that part, pinions, because we have real fine low speed control when it's unloaded. However, when it gets loaded down on the rocks, I can tell that it just has a little bit more load. So what we're going to do is go through the rocks. Now, keep in mind, we got a little more wheel speed than what we need. We also have the TGH overdrive gears installed into the front, 30 or 36% overdrive depending on how you do the calculations. An average calculation is 36%. A straight calculation of ratio difference is 30% higher ratio, higher rollout than the stock gears. And this little jittering that we're seeing is pretty much the ring and pinion needing to have a little bit better mesh. We got a little mud on our tires here, so like I always say, a little bit of wheel speed bump can get us through sections when we don't have traction. I'm currently running a Mamba X controller that has programming pretty much as outlined in my brushless speed controller programming guide. Check out that video if you have not seen it. If you'd like me to do a more updated video, I certainly can. See if I can avoid that passenger hole in that rear tire. It's gonna be a tough one. And the Capra showing its prowess as far as having belly clearance and clearance underneath the diffs. And since we are using a Mamba X, we have active brake on there, so I'll try to put on throttle and you can see it just really slowly edging down instead of free coasting. And we did increase the drag brake on the V2, so it has even less coasting. There we are. So still very tractable, lots and lots of drag brake. You know, I probably shouldn't do this because it'll pop gears, but it's got enough drag brake to essentially support the rig from one tire. Last time I tried to show that, I popped a gear in the axle, so I'll, you know, maybe not do that too much. No, I think that does showcase the rig's capabilities, the 2200 kV in particular on this Capra. Good match for it. I think I'm going to keep it in here because I really like the torque and the drag brake that this 2200 gives me. Not as much as something like a Revolver, but I get a lot more wheel speed than what I could get on a Revolver as well, so that's nice. Again, if you do have any questions about it that I didn't cover, if you want to see more vids, let me know in the comments. And as always, thank you for tuning in. Have a good day.